Okay, I think we can start. Dear colleague and audience, okay, good afternoon for the local people and good morning from the European participant. Okay, today is our great pleasure to introduce Professor Hanus Leitgeb to give the second lecture at the Wuhan University in the lecture series on logic and philosophy. Firstly, please let me to give some short introduction to Professor Hanus Leitgeb. In the first lecture, Professor Turnbull has given a very wonderful and comprehensive introduction to Professor Leitgeb. So it's hard for me to do better. But maybe some new audience join today's lecture. So anyway, I still prepare a few slides. Okay, you see, this is Professor Hanus Leitgeb, very young and handsome. Okay. Now titles. Hanus Leitgeb is an Austrian philosopher and a mathematician. He is a professor of philosophy at the Ludwig-Maximilians University of Munich and has received a Humboldt professorship in 2010. This passage is from Wikipedia. He is chair of logic and philosophy of language. He is also founder, co-director of the Munich Center for Mathematical Philosophy. Research interest. Professor Hanus Leitgeb has a wide research interest. He is very productive and had made many contributions to many fields. So you can see, first, logic, such as series of truths and modality, paradox, conditionals, non-monotonic reasoning, dynamical logic, epistemology, such as belief, inference, belief revision, foundations of probability, Bayesianism, philosophy of mathematics, such as structuralism, informal probability, abstraction, criteria of identity, philosophy of language, such as indeterminacy of translation, compositionality, cognitive science, such as symbolic representation, and neural networks, metacognition, philosophy of science, such as empirical content, measurement theory, history of philosophy, such as logical positivism, Carnap, Quine. He is very much in favor of mathematical or formal philosophy, such as the application of logical and mathematical method in philosophy. Okay, honors and awards. He is a member of International Academy of Philosophy of Science in 2011. He is a member of Academy of Science in Europe in 2014. A member of German Academy of Natural Science in 2016. Also, he has many other awards for excellence for teaching and publications. Okay, more information. Professor Hanus Leitgeb has 6 published books and 2 books in preparation, and many papers in top journals. For more information about his publications and academic services, just see his webpage. You can just Google his name, and then you can find his web link. Okay, in this lecture, he will talk about 90 minutes. During the lecture, the audience can write down your questions in the chat box. The staff at Xue Shuzhi will forward your questions to us. At the end of his lecture, Professor Hanus Leitgeb will give his replies. Okay, now let's welcome Professor Hanus Leitgeb give his second lecture. The title is Ramsification and Semantic Indeterminacy. Okay, please. Hanus Leitgeb, now is your time.
Thanks so much, Yong, for your very kind words. I really appreciate it a lot. Also, thanks for choosing another photo of my younger self. So I've already been asked right before my talk whether it's still the same person. So thanks for making the difference so obvious. Okay, it's a real pleasure to be back at the colloquium. It's lovely to speak at Wuhan, even though it's just virtual. And as I said already last week, I hope this will be the beginning of a lot of cooperation between our two places. Now, let me try to share my screen here. I hope this works fine. I hope you can see the slides fine. Yeah?
Yes.
Good, thank you. Okay, so last week, I was giving a talk in semantics. This was a talk on merely expressive devices, so including logical expressions, stipulatively defined expressions, metaphysical modalities, and how they work semantically. Today will be another talk in semantics, but the topic will be a different one. My topic today will be semantic indeterminacy and how we're going to deal with it in semantics. So the question is, what if meaning is indeterminate? Can we still more or less do classical semantics as we traditionally want to? So that's the question that I'm interested in. What if meaning is indeterminate? That might well be the case. If so, if meaning is indeterminate, if there is semantic indeterminacy, can we still do classical semantics as we're used to? Okay, and I want to say ultimately the answer will be more or less yes. Okay, there is probably semantic indeterminacy, but we will still be able to do something like classical semantics with a couple of twists and turns that I want to explain in my talk today. But now, why would you even think that there is a problem here? So there is something that I think is in tension, and my talk will be about finding a way of releasing that kind of tension. And the tension comes from the following assumptions. So, first of all, I think of classical semantics as a success story. So as far as I'm concerned, it successfully reconstructs the truth conditional meaning of natural language, mathematical language, and scientific language. Okay. Now, I know there will be some people in the audience who will disagree with that. Say you're a firm intuitionist, okay? Some kind of anti-realist in semantics, and you want to reject classical semantics for various reasons, okay? As you've heard already last week, you know, I have this bigger project of reviving logical empiricism. Part of that bigger project is a kind of tolerance and pluralism about logic. So in some sense, I'm happy if you were to choose a different conceptual framework for certain purposes, maybe an intuitionistic one. But I want to say that choosing a classical framework has proved to be very successful for various purposes, okay? And that's what I have in mind when I say classical semantics successfully reconstructs meaning in different kinds of languages, okay? From the logical point of view, right, if you have a classical semantic, say, for some, you know, language in mathematics, then you are able to prove certain truth theoretic laws that intuitively, pre-theoretically, you might have found plausible anyway, right? So, for example, you would be able to prove that for every number x, x is prime or x is not prime, okay? X is a prime number or x is not a prime number. That sentence, that universal quantified law, you will be able to prove as true, right, from your truth conditional semantics. And that's good because intuitively, pre-theoretically, we would have thought that's a statement that we should be able to derive as true in a semantics, okay? Now, secondly, and I will explain that early on in my talk, classical semantics comes with a presupposition. You might call that a meta-semantic presupposition, okay? So the idea is there's not just, semantics proper, which is concerned with, you know, truth conditions, but also meta-semantics, right? Something that explains in virtue of what a certain sentence has a certain truth condition, okay? And in that meta-semantic part of classical semantics, there is a presupposition, namely the presupposition of the existence of a uniquely determined intended interpretation, okay? So you're dealing with some kind of object language, you want to deal with meaning for that language, so you introduce a classical semantics. And when you do that, you presuppose in classical semantics that there is always this uniquely determined intended interpretation of the symbols in the object language, right? For example, for the predicate prime, classical semantics presupposes a uniquely determined interpretation of that predicate. That might be the set of prime numbers, right? That's the intended interpretation of that predicate prime, okay? So when I say here I of prime, that's a set, the intended interpretation of the predicate prime, and that set is a subset of the suitable domain, namely, say, the set of prime numbers in that domain, okay? And that's something that is, not dealt with necessarily when you're dealing with classical semantics, but it's a kind of presupposition that lurks in the background. And that leads to the problem because it seems that many fragments of natural language, mathematical language, and scientific language, there is no uniquely determined intended interpretation. Okay? So the presupposition that classical semantics seems to make is likely to be false. In certain cases, it's hard to sort of prove, right, that there is no uniquely determined intended interpretation, but you still can run arguments in favor of the thesis that there is no uniquely determined intended interpretation. And I will give you some examples later. So I think for many fragments of natural, mathematical, and scientific language, it's quite likely, at least, that there is no uniquely determined intended interpretation. Hence, the presupposition that classical semantics comes with is false. And that leads to the question, how come classical semantics is still so successful? Okay. And furthermore, once we take into account that that presupposition of classical semantics is false, what are we left with? Okay. Is there a way of saving most of classical semantics while at the same time giving up the presupposition of the existence of a uniquely determined intended interpretation? Can we stay ultimately very, very close to classical semantics, but leave open whether there is a uniquely determined intended interpretation? Okay, and I want to argue this is possible, and that's what I want to develop in my talk. At the end of my talk, I will have given you a new kind of semantics, if you like. I will call it Ramsey Semantics, which is the result of Ramsifying classical semantics. I will explain later what I have in mind with that, and that Ramsey Semantics, that Ramsification of classical semantics, will stay very, very close to classical semantics. Okay, so close that basically everything that classical semantics was successful with, also Ramsey Semantics will be able to do successfully. So we'll keep enough to keep the success project alive, but Ramsey Semantics will not come with that presupposition of the existence of a uniquely determined intended interpretation. Okay, so Ramsey Semantics will, in a sense, be more liberal. It allows for cases where there is more than one intended interpretation available. Okay, or as I will say later, more than one admissible interpretation. Okay, so it does not necessarily buy into that presupposition of classical semantics, and hence it's less risky to do Ramsey semantics than classical semantics, because, as I said, that presupposition of classical semantics might well be false. So it's good if we don't buy into it in Ramsey semantics, okay? So just as a little warm-up example, on the natural numbers, mathematicians understand the prime predicate to have a uniquely determined intended interpretation. There's nothing problematic about it, right? So it's this thing about, being greater than 0 and 1 and, can only be divided by 1 or the number itself. That's a prime number. That's fine for the natural numbers, okay? But once you go beyond the domain of the natural numbers, say in your intended universe of discourse, you throw in further objects, right? Maybe you're studying, a more general algebraic structure, maybe a ring, okay? Then all of a sudden, it turns out that what was uniquely determined before, being prime, now bifurcates into maybe two concepts or more, okay? So over a ring, okay, you can be interested in the prime elements of a ring, but you can also be interested in the irreducible elements of a ring, okay? And extensionally, they do not necessarily coincide, okay? So what had a uniquely determined intended interpretation, namely the predicate prime over the natural numbers, right, might not have a uniquely determined intended interpretation anymore once you go to bigger domains, okay? So on a bigger domain, what was uniquely determined before could now either mean a prime element or it could mean irreducible element, okay? You do not have necessarily to think that the predicate prime is semantically determinate on all domains. Okay, you can leave open that there is more than one intended interpretation beyond the natural numbers. Okay, if that example doesn't convince you, that's perfectly fine. I'll give you way more examples later that I think will make it very likely that the thesis of semantic determinacy is likely to be false. Okay, so I want to get rid of that false presupposition of classical semantics. Okay, so in what follows, I will make a proposal for how to release this tension, save enough of classical semantics to keep the success project alive, but do not buy into semantic determinacy. And the key idea of releasing the tension will be to apply a method that is well known from scientific theory reconstruction, so from general philosophy of science, but we will apply that method now in a domain where it's not usually applied, namely in semantics. Okay, and that method is Ramsification, famous method of theory reconstruction that goes back to Frank Plumpton Ramsey, which has been used a lot by the logical empiricists like Rudolf Carnap. As I said last week, I have this bigger project of reviving logical empiricism, of ending up with an enlightened version of logical empiricism that saves some of the basic tenets of good old logical empiricism, but changes things in a way to repair the mistakes that the logical empiricists made. I told you about one of these mistakes last week. I don't want to give up metaphysics anymore. Okay, so part of my new story, of my new revival of logical empiricism, is of how to give a new story about metaphysics. I alluded to that at the end of my talk last week. So metaphysics is about the building, the construction of conceptual frameworks. What I will talk about today is using a method that the logical empiricists like to use for scientific theory reconstruction, but apply it in an area where it's not usually applied, and that is semantics. Okay? More about this a bit later. So here is the plan of the talk. I will first give you a sketch of what I mean when I speak about classical semantics and meta-semantics. Okay? So that's the thing, that's sort of the starting point. Okay? That's the orthodoxy. Then I will challenge that orthodoxy on grounds that I've already explained now, namely semantic indeterminacy. So basically, I will give you 3 examples that I think make it likely that semantic determinacy, the unique existence of intended interpretation, is false. Okay, probably there is more than one intended, or as I shall also say, admissible interpretation in these 3 example cases. Okay, so there is a problem here. Classical semantics rests on a presupposition that is false. And then I will develop Ramsey semantics, that Ramsification of classical semantics, in order to rescue, as it were, classical semantics from that challenge of semantic indeterminacy. Ramsey semantics will keep a lot of classical semantics on board, but give up the presupposition of semantic determinacy. Okay, Ramsey semantics will be able to live with semantic indeterminacy. That's fine. I do not say that Ramsey semantics is committed to semantic indeterminacy. It just leaves it open. Okay? Whether there is a uniquely determined intended interpretation or not, Ramsey semantics will be able to deal with it. In the 4th part of the talk, I will compare Ramsey semantics then with supervaluationism. So that's another famous way, maybe the most famous way, of keeping a lot of classical semantics and especially classical logic alive, and yet not buy into semantic determinacy. And I hope I will be able to argue successfully that Ramsey semantics is a bit better than supervaluationism in the sense that it stays closer to classical semantics than supervaluationist semantics does. Okay, and I will also say more about the comparison between Ramsey semantics and classical semantics. Okay, and then I'll return to my 3 examples, these 3 cases where I argued that in these 3 examples, 1 to 3, it's likely that there is semantic indeterminacy, and I will show you how Ramsey semantics is going to deal with these 3 examples. And at the end, I'll draw some general philosophical conclusions. That's the plan. Okay. Now, let me start with my sketch of classical semantics and meta-semantics now. So if you want to do semantics in a way that is interesting for the linguist, say, okay, then immediately you should start with an intentional semantics. Okay. However, in order to simplify things, I will only deal with extensional semantics in my talk today. This is not that you couldn't run the same talk for intentional semantics. You could. Okay, so I want to say there is semantic indeterminacy with respect to extensions of predicates, But there is also semantic indeterminacy, presumably, with respect to intensions of predicates. Okay? You can Ramsify extensional classical semantics, which is what I'm going to do in my talk today. You can also Ramsify classical intentional semantics. It's just that extensional semantics is a bit easier to deal with. It's simpler. So it's natural to start with the simpler case. And once you get the idea how it's done there, I'm sure you will be able to extrapolate from that to a Ramsification of classical intentional semantics. Okay, and at least in philosophy, extensional semantics is still a very interesting topic. Okay, so for example, if you're working on formal theories of truth, then usually you do extensional semantics. That's good enough for your purposes, okay? And then you give a semantics for some first-order language that you're interested in. That first-order language might be the formal reconstruction of some fragment of natural language. It will be a very restricted fragment, so it won't include intentional operators normally, okay? But all of that is fine for the purposes of my talk, okay? And I hope you will get the idea of how to extend the same scheme, the same idea, if you're interested in studying semantic indeterminacy in bigger formalizations of bigger fragments of natural language. So let L in the following be some kind of formalized fragment of natural, mathematical, or scientific language. And in most cases, you can just think of L being some first-order language that you're interested in, okay? Now, classical semantics then defines what an interpretation is, an interpretation F, and that is just a function that assigns references and extensions to the members of the descriptive vocabulary of the language over some domain. Okay, that's also given by the interpretation. So, think of a Logic 101 course. Okay, you introduce a classical model or a classical interpretation. Then this is nothing else than assigning certain references and extensions to singular terms and predicates in the descriptive vocabulary of your first-order language over some universe of discourse, okay, that is also given with the interpretation mapping, okay? Now, I leave certain things open. So you could ask me, for example, Hanus, what's your meta language like? So what I'm talking here is in the meta language, okay? So this sentence about interpretation mappings of the object language L, that's a sentence in the meta language. And now you could ask me, take the variable F, okay? It's a variable in the meta language. What is it like? What kind of variable is it? Okay, is it a first order variable or is it a higher order, say a second order variable in the meta language? I will leave that open. Okay, so for most purposes, you could think of the meta language as being another first order language. Okay, that includes enough mathematical symbols like set theoretic symbols, because we like to give a classical semantics in set theory these days. But if you prefer, you could also give your semantics for this first order language L in a second order language. And then maybe the F symbol, that variable, will be a second order variable, okay? If you wanted to make sure that, for example, the quantifiers of your first order language L, of the object language, they are meant to range over absolutely everything, okay? So that's a special topic in philosophical logic and philosophy of logic. If you were interested in that, then maybe you would prefer giving your classical semantics in a meta theory that is second order, okay? Because that might allow you to quantify over everything in the object language, okay? But if this is less important, you're only interested in quantifying over the natural numbers in the object language, then that's not a topic, okay? So I'll just leave that open. If you're interested, we can talk about it later, but it's mostly orthogonal for the purposes of my talk, okay? The third part is then you define the satisfaction relation. So you say under which conditions a formula A in the object language is satisfied by an interpretation mapping F. And here you give the standard recursive Tarskian clauses, okay? So for example, an atomic formula P of A is satisfied by an interpretation function if and only if what is assigned to the, say, individual constant A by the interpretation mapping F is a member of the extension that is assigned to the predicate P, a unary predicate, by the interpretation mapping F. Okay, and the like for binary and ternary predicates and so on and so forth. Okay, and then you have the standard satisfaction rules for negation and disjunction and quantification and so on. The usual compositional truth conditions that Tarski told us how to assign relative to an interpretation mapping. So that's basically model theory, if you like. Okay. And in the background, of course, we have the idea that the negation symbol is a classical negation symbol, the disjunction symbol is a classical disjunction symbol, and so on and so forth. Okay, and this shows up on the right-hand side in the truth conditions. Now, the fourth part that we need in classical semantics is we define logical consequence as classical logical consequence, and that's just defined by, truth preservations in all interpretation mappings. So A1 to AN logically implies C, just in case whenever the premises are true, the conclusion is true, and truth means being satisfied by an interpretation mapping. And the whenever the premises are true, the conclusion is true, that is captured by quantifying overall interpretation mappings F. Okay, so then we have logical consequence. Next step, now we want to say that when we want to give a semantics, okay, when we want to assign meaning to a particular object language that we're interested in, we are not really interested in all interpretation mappings whatsoever, but just certain ones that we call intended or admissible. I will use these terms interchangeably in my talk, okay? So amongst the interpretations of the object language, we assume that there is a certain subclass of intended or admissible interpretations, okay? Those that get sort of the intended meaning of these predicates and singular terms and so on of the object language right. Where do these intended or admissible interpretations come from? Well, that's a bit tricky to say, but in general terms, they come from linguistic facts concerning competent usage of predicates and singular terms in L. Okay, so as far as the predicate prime in my initial example is concerned, you would look how it is used by mathematicians, say by number theorists. Okay, and that gives you then a definition of prime. Maybe you look at how they define prime. Okay, and those are linguistic facts, and they will partially determine your intended and admissible interpretations. Okay. Then secondly, there will be some non-linguistic facts that are also relevant. These will be non-linguistic facts that are relevant as to whether some atomic formulas are satisfied or not. Okay. So for example, there will be mathematical facts that tell you what satisfies the definiance in the definition of prime. Okay. So this will tell you that, for example, 2 satisfies the definiance of prime. Okay. But 4 does not satisfy the definiance of prime. These are mathematical facts. If the predicate is an empirical term from a scientific language or from natural language, then the non-linguistic facts will not be mathematical facts, but facts concerning the natural world, the empirical world out there. Okay, and there will be some laws, that's the third part, that make it the case that the linguistic facts, together with the non-linguistic facts, okay, conspire to ultimately determine the intended and admissible interpretations of the predicates and singular terms of the object language of your interest. Okay, ultimately, for some of these meta-semantic laws, when you want to say how this determination process is carried out, as it were, in some cases you will be able to write down these meta-semantic laws. Okay, and in other cases, we will just, when we do semantics, presuppose that somehow the intended interpretations are determined, even though it might still be open to further scientific research of how the determination process actually comes about. Okay, so here's an example. Okay, so that's a Putnamian, goes back to Hilary Putnam, a Putnamian example of such a meta-semantic determination law, meta-semantic law. Okay, so Putnam argued that for all kind terms, okay, say the term is the predicate tiger or something like that, okay? For all objects D and D prime, if the meaning of the kind term K is collectively specified by pointing at an object. So initially, someone pointed at a particular tiger and said tiger, okay? Like an act of baptism, okay? While being interested in the physical structure, if it's about tigers, that's probably the biological structure, okay? And then there is an object D prime, okay? At some time later, some different place, another tiger runs around, which has the same biological structure as the one pointed at initially. Then, if this object D prime is in the universe of discourse of your intended or admissible interpretation function, okay? Then if the one is counted as a tiger, okay, falls under the predicate, falls under the intended interpretation of tiger, then the other one does so too. Okay, so initially you pointed at something, said tiger, okay, there is this other object D prime, okay, that is similar enough, as it were, in biological structure to the original one, okay. Since the original one falls under the extension of tiger, the other one does so too. Okay, so this kind of law that I've just stated, that goes back to Putnam, that is one of these meta-semantic determination laws that I have in mind here in 3. Okay, there are Kripkean laws that are to do with baptism and causal transformation in time and so on and so forth. Okay, so there are lots of these meta-semantic laws. Some of them we'll be able to write down. For others, it will be hard to write down, but we assume that they are there. And ultimately, what it gives us is a set of admissible or intended interpretation that basically get the correct usage right. Okay, that gets the practice and the patterns of usage that are out there when people talk with that object language, that get it right, and it's captured by this set that I will call ADM of admissible or intended interpretations. Okay, so that's the idea. So to some extent, you could say if you do semantics, then usually you buy into a thought that the intended interpretations or admissible interpretations, they supervene on usage in some way. Okay, and I've just tried to unpack that statement a little bit by looking at the different ingredients. So you could say that the one part, the linguistic facts, that determines intentions. Okay, then you add 2 in order to get from the intentions to the extensions. Okay, and how this all is related, that's given by these meta-semantic laws. Okay, very roughly. And now what makes it particularly classical, okay, is the following idea, that actually the set of admissible or intended interpretations, that just comes with one member. The set of admissible or intended interpretations is a singleton set of the uniquely defined, uniquely specified intended interpretation. So that's a presupposition that classical meta-semantics adds to what I just mentioned. So my Ramsey semantics, or also supervaluationist semantics, they will also presuppose that there is this class of admissible interpretations. That's fine. But what classical semantics adds to this is that this class is actually a singleton set. It has a unique member, the uniquely determined intended interpretation of the object language that you're interested in. That will be the presupposition that I want to give up in the rest of my talk later. Okay, but it's part of the classical semantics, or in this case, if you prefer, meta-semantic package. Okay, the uniquely determined intended interpretation, this I function, is meant to convey the uniquely determined intended interpretations of predicates in singular terms. It gives you the intended universe of discourse, okay, and ultimately it gives you the actual truth values of the sentences of your object language. So that's the final part of classical semantics. You define classical truth in the way that for all sentences A in the object language, A is true just in case it is satisfied by the uniquely determined intended interpretation. Okay, and satisfaction we've already defined. That was part of what I explained before. So 1 to 7 taken together, for me, that is what I want to call classical semantics. That includes classical semantics and meta-semantics. And now the main problem is, I think it's dangerous to presuppose 6. It's dangerous to presuppose semantic determinacy, for it might well be the case that there is semantic indeterminacy. There is more than one intended or admissible interpretation of the object language L. Okay, so the question is, what if meaning is indeterminate? What if ADM, that set, has more than one member? Okay, then 6 is false, and it's no longer clear that we get anything resembling classical semantics because we need to give up that presupposition of classical semantics. Okay, but how can we then reap the fruits that classical semantics gave us? How can we save the success story that I think classical semantics is? That's the question. Okay. Now, why do I think that it's very likely that for many, many cases, for many, many object languages that we're interested in, ADM is going to include more than one member? Okay. Let me give you 3 examples. And in each of them, I want to argue it's plausible to think that there is more than one member in ADM. More than one intended or admissible interpretation. So the first example is a very familiar one, I take it, and that's vagueness. Okay, so I will understand vagueness as a special form of semantic indeterminacy, okay, as David Lewis did famously. So let L now formalize a fragment of natural language, say with one of these typical vague predicates, like the predicate bald. Okay, this reminds me of the discrepancy between my appearance now and the photo that Yong started with. Okay, yeah, I hope you get the idea. Okay, so we know something, right, about ADM in that case. That is, we know something about admissible or intended interpretation that basically get right how we use the term bald in English. Okay, so for example, and if an interpretation mapping F is in ADM, then we know that 0 will be in the interpretation of bald. Okay, so whatever the intended or admissible interpretation in ADM is like, okay, having 0 hair on one's head will count as a case of baldness. Okay, so that is clear. Yeah, that's determinate, I will say very soon. Okay, and it's also determinate that once a person has 100,000 hairs on their head, okay, that person will not count as bald. In fact, it will count as not bald. Okay, that's also determinate. That will also be true for all admissible interpretations. Okay, but it seems unlikely, okay, that there aren't any borderline cases. That is, it seems unlikely that there is a uniquely determined intended interpretation I that is a member of ADM. Why? If there was such thing, such a uniquely determined I, then it would be the case that for every natural number n, possible number of hairs, either the semantic constraints would determine that n is interpretation of bald, okay, or they would determine that n is not interpretation of bald, okay, because the meta-semantic constraints would, okay, if ADM is a singleton set, would determine just one intended interpretation. And if there is just one intended interpretation, you have the excluded middle. Either n is a member of the intended interpretation of bald or n is not. Okay, so meaning the meta-semantic constraints would determine for every n whether n is a bald case or not a bald case. Okay, but that's implausible, I want to say, because at least prima facie it's plausible that there are borderline cases. Okay. There are cases where one may competently ascribe bald to a person with n number of hair, but where you may also competently refrain from ascribing bald to that person with n hair and indeed ascribe not bald. Okay, so that seems plausible. Somewhere in between 0 and 100,000, there is borderline cases. And it could be, you could say it's a bald case, you could say it's a not bald case, okay? Meaning there will be at least 2 interpretation mappings in your set ADM, okay? So that's the idea. There's more than one intended and admissible interpretation in that case, okay? So vagueness. Vagueness is a famous case where you want to say that there is more than one intended interpretation, okay? Now, here's my second example. Take the object language to be the language of second-order arithmetic. Okay, so we have a predicate for the natural numbers, we have a singular term for 0, we have maybe a successor function symbol or predicate, we have something for addition and multiplication and so on. Okay, so now we're interested in the meaning, in the semantics of the language of second-order arithmetic. Okay, so maybe you want to do philosophy of mathematics, and that's why you're interested in that. Maybe you're just a semanticist, okay, and you want to give a semantics for arithmetic for some other reason. Now, let's assume for the time being that you're also a set theoretic and eliminative structuralist about arithmetic, okay? Then here is something that you want to claim, and people have claimed that in the philosophy of mathematics. They have claimed that actually the interpretation of the arithmetical symbols is only determined up to isomorphism. So the set of all admissible or intended interpretations of the language of arithmetic is the set of all interpretation mappings F that satisfy the second-order Dedekind piano axioms for arithmetic. Okay, why would you get the idea? Famously, Dedekind has proven that the second-order Dedekind piano axioms for arithmetic are categorical. So they pin down, as it were, the intended interpretation of the arithmetical symbols up to isomorphism. Okay? And so if you collect all the interpretation mappings that satisfy these axioms, okay, you will get lots and lots of isomorphic interpretations of the second-order language of arithmetic. Okay? You will get different interpretation mappings or models. They're all pairwise isomorphic. They all save the structure of arithmetic. And if you are a set theoretic structuralist about arithmetic, you want to say everything that's to be saved about arithmetic is structure anyway. Okay? The proper mathematical content of arithmetic is given by the structure of the natural numbers and nothing else. Okay, it's unimportant which sets, which objects realize that structure. It's just the structure that counts. Okay, so you want to say as a set theoretic structuralist that the set theoretic symbols, their meaning is only given up to isomorphism anyway. There is no uniquely determined interpretation, but in fact, you can prove that there are infinitely many pairwise isomorphic set theoretic interpretations. So there's infinitely members of ADM. They have a lot in common, namely assigning the same structure to arithmetic, but numerically speaking, they are different. Okay, the ADM is not a single set, but an infinite set. Okay, now this is not to do with vagueness. So it's not that, the natural number predicate or so, or the function symbol for addition or so are vague terms. They are not. But the set theoretic structuralist wants to say they are still semantically indeterminate. Okay, they do not have a uniquely determined intended interpretation because only their structural content sort of is fixed. Okay, but there are lots of set theoretic ways of realizing that structure, and all of these interpretations that satisfy the structure, that satisfy PA2, that second order axioms, all of them count as members of the set of admissible or intended interpretation. So this is a case of semantic indeterminacy without vagueness. Okay, so it's not necessarily about vagueness. My talk is not just dealing with vagueness, but with semantic indeterminacy more generally understood. Okay, now here's the thing, you might say, but what if I'm not this kind of set theoretic eliminative structuralist about arithmetic? Maybe they are wrong. Okay, maybe, for example, you might be a structuralist about arithmetic. Okay, but you're a non-eliminative structuralist, a non-set theoretic one. You might say, actually, there is a uniquely determined interpretation of the arithmetical symbols because there is the natural number structure. It's just that natural number structure is not set theoretic. Okay, it's enter-rem. It's a kind of structure over and above the sets. Okay, so that's a position that you also find in the literature. Okay, I have some sympathies to that. Okay, so Stuart Shapiro, for example, would have argued for that, and others. Okay, now here's the thing: if you were that kind of structuralist, okay, you would still think that certain mathematical terms are semantically indeterminate. Okay, so for example, say you don't want to do arithmetic, but you want to do complex analysis. Okay, the analysis of complex numbers. Okay, so then the language you would have term by which you are able to talk about complex numbers. For example, the imaginary unit I. Okay, but then if you're that kind of structuralist, you would say that actually up to structure. Okay, it doesn't really matter whether the symbol I. Okay, really means means I, okay, or it means minus I, okay? It means the complex unit or the one minus the complex unit, okay? Because whether it does, okay, it doesn't really matter up to isomorphism, okay? Structurally speaking, you get everything right, okay? So even if you thought there is a uniquely determined structure of the complex numbers, you still want to say that the individual constant quotation mark I quotation mark in your object language, it's semantically indeterminate whether it denotes the one imaginary unit, okay, or minus that, okay, because there is an isomorphism of the complex field that takes the one to the other anyway. Structurally speaking, it doesn't really matter, and you're still a structuralist, even though you might be a non-eliminative structuralist. Okay, it's only the structure that is important. So that's why also non-eliminative structuralists like Stuart Shapiro have argued that there is something semantically indeterminate about certain mathematical symbols. Maybe not about the arithmetical symbols, but then it's other symbols in mathematics that are still semantically indeterminate. Either way, you get semantic indeterminacy. Okay, so at least if you're a structuralist of some kind of stripe. Okay, so at least if you're a structuralist, you think that there's semantic indeterminacy about mathematics. Okay, so that's my second example. And my third example, that's to do with a scientific language now, say the language of mechanics, of physics. Okay, say it's the language of Newtonian mechanics, and you have the term mass there. Again, I leave it open. Is this a function symbol, a predicate? It doesn't really matter for my purposes now. Okay, so Hartree-Field, back in the 1970s, famously argued that the term mass, as being used by the Newtonian physicists, is semantically indeterminate if looked at from the modern relativistic point of view. Okay, so if in the meta language we are using the best language that we have, the language of modern relativistic mechanics, you find actually that the mass term in Newtonian mechanics is semantically indeterminate. Because from the modern point of view, there are two possible intended interpretations, and there is no fact of the matter which of them is the right one. Okay, so it doesn't make sense to say, Hartree-Field argued in that paper, that the Newtonian physicists there was a fact of the matter which of the two the Newtonian physicists meant with the term mass. There is no fact of the matter. Both of them are maximally charitable from the modern point of view when you interpret the language of Newtonian mechanics, okay? Because from the modern point of view, the intended interpretation of mass could either be what Hartree called relativistic mass, so that's the total energy of a particle divided by the square of the speed of light, or the second interpretation would assign to mass proper mass, that is the non-kinetic energy of a particle over c square, okay? They can come apart in value, but both interpretations save as much as possible from the Newtonian interpretation, as it were. Okay, so with both interpretations, you save most of Newton's central claims. Okay, so his laws with respect to objects that do not move too fast. Okay, his experimental findings and so on. Okay, you can't save everything of Newtonian mechanics because Newtonian mechanics, strictly speaking, is false from the modern relativistic point of view. But if you want to save as much as possible, you want to be maximally charitable with respect to Newtonian mechanics, okay, there is two ways of saving as much as possible. In one, you interpret mass in the one way. In the other case, you interpret mass in the other way. There is no fact of the matter which of the two is meant. So there is more than one admissible or intended interpretation if the object language is the language of Newtonian physics. Okay, so this is yet another case of semantic indeterminacy without vagueness. Okay, that's not about vagueness. Here it's to do in some sense with problems, incongruences, as it were, okay, between an old scientific language and the scientific language that we currently use and that we would also use when we do, for example, linguistics, that is when we use semantics in the case here. Okay, so that's my third example. And again, it's likely in that case that there is semantic indeterminacy. Now, how would you react? Okay, so I give you that challenge. Probably your presupposition is false, I say, to the classical semanticists. What do you do now? Okay, now in the literature, okay, you find ways of responding to that challenge, and one of that is epistemicism. Okay, so that's really concerned with semantic indeterminacy as far as vagueness is concerned, less so with the other cases. Okay, and one of the prime examples would be Timothy Williamson, but you know there are other epistemicists as well. And what someone like Tim would suggest is, no, I want to stick to classical semantics and meta-semantics. There is this uniquely determined intended interpretation I won't give up that presupposition. But then he wants to say that, no, vague terms are not semantically indeterminate, okay? So you can still think of them being vague and explicated, but maybe by means of counterfactuals. But you assume that complete extensions, say for the predicate bold, are somehow determined by the facts we might just not know, and we might never be able to know how this comes about. Okay, so roughly the meta-semantic laws might be really complicated. Okay, so you're right. You know, at first glance, you might have thought that it's unlikely that, but no, the meta-semantic laws do the job. I don't know how. Okay, but they do the job. Okay, so that's he would say. Okay, about arithmetic, right? You know, an epistemicist might say, no, actually, you might have thought that arithmetic is given by its structural content, but there is more to arithmetic, and that will pin down the intended interpretation. Okay, so Benesserev famously, looked at set theoretic interpretations of the arithmetical symbols and said, look, which finite ordinals do you mean? Okay. Do you mean von Neumann ordinals, or do you mean Zermelo ordinals? There might not be any fact of the matter, because structurally speaking, it doesn't matter. But the epistemicist might say, no, there's something about arithmetic, the practice of doing arithmetic, that will say it's really the von Neumann ordinals that you find in the intended interpretation, not the Zermelo ordinals. Okay? And if you open up a set theory textbook, set theorists might actually go for one interpretation, okay, by fiat. Okay? So, maybe that's the defense that the epistemicist has. Okay, and for mass, they might just again bite the bullet and say, no, mass as used by Newtonian physicists does come with a uniquely determined intended reference. Okay, it might be hard for us to find out what it is, whether it's proper mass or relativistic mass, but somehow, some practice that the Newtonian mechanics had made it that the one is the intended interpretation and not the other. Okay, And there are other challenges, similar challenges that you find in Quine and Putnam and Kripke and Saul Pfefferman and Mark Wilson. They all can be interpreted as arguments in favor of semantic indeterminacy. And the epistemicists would always say, no, they're wrong for this reason and that reason and so on. Okay? Now, my worry about all of that is, it seems that in each of these cases, the epistemicist has to come up with a special story. It will be a kind of piecemeal defense that has to work in each case for different reasons. Okay, so in the case of vagueness, there will be a reason why epistemicists think that classical semantics holds something to do with meta-semantic laws and so on that work. Here, it's basically no, structuralism is wrong. Okay, and here it's about the views that Field argued for, his interpretation of revolutions in science that lead to indeterminacy, that's wrong. And, Kripke and Pfefferman and Putnam and Quine and Wilson, they were wrong for different reasons. It will be piecemeal. And I find it questionable that this kind of strategy is going to work. Okay. There might be another comeback that the epistemicist has, and this is probably something that Timothy Williamson would run. He would say there is a broader abductive argument in favor of this presupposition of a uniquely determined intended interpretation. And basically the idea is, classical semantics is such a success story, and the only way to save that success story is to buy into that presupposition. Okay, so the only really explanation that we have for why we get all these successful statements of classical semantics is that we need to buy into that presupposition. Okay, so it's a kind of inference to the best explanation, something like that. Okay, but that won't work either. I want to argue for the rest of my talk, because you can save what was successful about classical semantics without buying into that presupposition. Okay, and Ramsey Semantics will do the job. That will be my argument. Okay. Now, a second possible reaction to the challenge from semantic indeterminacy is supervaluationism, famously, going back to Bas van Fraasen and Kit Fine and others. Okay, so again, the idea is, like I want to say, do not assume that there is semantic determinacy. Do not assume that there is a uniquely determined intended interpretation. But what they will change instead is they will change classical truth to supertruth. Okay, so in the truth definition, they don't take the classical truth definition, but they will rather say A is true, that is super true, just in case A is satisfied by every interpretation mapping that you find in your set ADM, by every intended or admissible interpretation. Okay, generally there will be more than one such F. Okay, and A will count as true if it's made true by all of them. Okay, and it's false, super false, if it's false, made false by all of them. So they change the truth definition. That's their way out. Okay, but again, this leads to problems that have been discussed a lot. Again, Timothy Williamson in his book did so very successfully, I thought. So you don't get a compositional semantics anymore, because super truth and super falsity, they are not compositional. Okay, you don't get these compositional Tarskian clauses. Okay, and there are also some logical problems. Okay, that's another problem. So if you beef up your object language a little bit, you throw in, say, a determinately or definitely operator that captures super truth in the object language. Okay, and then you look how naturally logical consequence would be defined by supervaluationists, namely as super truth preservation. Okay, you see that, for example, a sentence A would logically apply in supervaluationist semantics. It is determinate that A. Okay, so that would hold. Okay, that's a fact about logical consequence now in your supervaluationist semantics. But it's not the case, generally speaking, that it is logically valid that if A, then determinately A, but this is now the material conditional. Okay, so you get the one, but not necessarily the other, which means a famous meta rule of classical logic fails. In this case, the meta rule of conditional proof. Okay, and there are other meta rules of classical logic, contraposition, indirect proof, and so on, okay, that you won't get out of that supervaluationist package, okay? So in some sense, you change classical logic. So supervaluationists always claim we save classical logic, and that is right if you just look at the classical logical rules, but it's not right in general, okay, if you look at the classical logical meta rules. Okay. Once your object language is expressive enough, you throw in this determinately operator and you define logical consequence sort of in the obvious way, a super truth value preservation, then some meta rules of classical logic are not saved. Okay. So I take that as a problem because I started with the idea that, there's a lot that classical semantics got right, that package got right. And I think there's something that it got right about the classical meta rules as well. So it's a problem if you don't save them. Okay. Now I should say there are ways out for the supervaluationist. Okay. So this is what I hinted here at is a global way sort of defining logical consequence as a supervaluationist. There are alternative ways of defining logical consequence that would not suffer from that problem, but people like Tim Williamson argued they would suffer from other problems. Okay. So there is a problem that supervaluationism has. It doesn't stay close enough to classical semantics. Okay. Ramsey Semantics, which I will suggest now, propose now, develop now, stays closer to classical semantics than supervaluationism does. Okay? So here's my alternative proposal. It will preserve classical logic, and it will preserve classical truth in a sense. So once again, the idea will be, basically, accept everything that you find in classical semantics, but do not assume that there is a uniquely determined intended interpretation. Allow for semantic indeterminacy. Okay? Basically, we leave open the cardinality of ADM. It might be a singleton set, who knows, for certain object languages, but it might also be a set with, two members. It might be a set with infinitely many members. It depends, and we want to leave that open. Okay? Now, the idea is now, take those terms in the classical semantical package that you can view of as theoretical terms, as it were, for the semanticist. And those terms are the term intended interpretation and the term true, the truth predicate. Okay? Look how they are introduced in the classical package. Basically, what's important is that we want to say that the intended interpretation is a member of ADM. Okay? So it basically conforms to the way we use the term. Okay? And for all sentences A is true, just in case A is satisfied by I. Okay, so that I want to say is the basic theoretic ingredient that captures the meaning, the theoretical content of these terms I and true that you find in classical semantics. Think of them as theoretical terms and now Ramsify them away. Okay, so what does that mean? Ramsification means you replace these theoretical terms by corresponding variables of the same type. Okay, and then the resulting open formula you existentially quantify. So what you get in that case is you say there is an F, there is a T, a set T, if you like, okay, such that F is a member of ADM, and for all sentences A is a member of T, just in case F satisfies A. So we've replaced the I by F, a variable, and we've replaced the truth predicate, by T, okay, maybe a singular term for a set, and then we existentially quantify the corresponding open formula, and that's the Ramsey sentence that we get out of that theory. Okay, so in a slogan, the idea is Ramsify classical semantics. Now, in the tradition, people like Ramsey and the logical empiricists, they would maybe have Ramsified away theoretical terms in natural science, in physics, maybe the predicate electron. Okay, and what they would not Ramsify away might have been observation terms. That's not what I'm interested here. Okay, there is a broader picture of Ramsification that you find in David Lewis, where basically you have some terms, some old terms that you think are already sufficiently understood, or you presuppose them to be sufficiently understood. Okay, and then there are some new terms. Those are the terms that you Ramsify away. Okay, what I presuppose as understood is ADM. That predicate, or that maybe it's a singular term for a set again, okay? So that singular term I will presuppose, like classical semanticists do, and like the supervaluationists do. And I'm not Ramsifying it away, okay? But what I Ramsify away is the term for the intended interpretation of the truth predicate, okay? Also note that I do not say anything like this. For example, A is true just in case there is an F, blah, blah, blah. So the existential quantification is not narrow, right? It has wide scope over truth. I say there is an admissible interpretation F such that, and then basically truth is given by it. Okay, so it's a wide scope existential quantification, not a narrow scope one. Okay, so don't mix that up. If we had the existential quantifier here in the truth definition, narrow, okay, then basically we would do something like supervaluationism, but it's really called subvaluationism, okay? Because you would think that truth is not given by being true at all admissible interpretations, but truth is given by something is true if there is an admissible interpretation that blah, 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 okay? So the dual, as it were, supervaluationism. But that's not what I have in mind here. Okay, there is an F that is admissible such that truth is given by it. That is what I'm suggesting here. Okay. Now there is an alternative, an even nicer way, but it's precisely the same idea. It's just a different presentation. In some sense, a nicer presentation. Okay. Instead of doing it by sort of, existential quantification from the start, by looking at the Ramsey sentence, there is something else that you could do. You can use in your meta language instead epsilon terms. Okay, so you're a semanticist, you have a meta language, and now I suggest add a new logical symbol, an epsilon operator, to your language, and use that epsilon operator in your meta language. Okay. Now, what's an epsilon operator? So epsilon terms were introduced famously by David Hilbert and his whole Göttingen school as a tool in meta-mathematics. Okay. So they had this idea that, they are sort of denoting ideal elements. Okay. Maybe, lines at infinity in geometry or, something like that. Okay. And then they wanted to use these epsilon terms basically in order to give consistency proofs of certain parts of mathematics. Okay, so it was a logical device that was useful for Hilbert's program at the time, roughly speaking. Okay, I'm not interested in Hilbert's program right now. Okay, but I want to use the same device and recycle it here for different purposes. So what it is, if you take a formula in a meta language and you have a variable x, then you put them together, you say epsilon xa, and you think of that as an individual term. It's an indefinite description. So a definite description would be the x such that a, right? The x such that x is present king of France or something like that. But the epsilon term is indefinite, where the definite description operator, the iota operator, is definite. So epsilon is really an x such that a. Okay, so the idea is roughly amongst the things that satisfy A, you pick one, but there might be several things that are A. Okay, you pick one, but you leave it indeterminate which one of the A's is picked. Okay, you just choose an X such that A. Now, already the Hilbert school had some logical axioms for the epsilon operator. So there is some axiom that says there is an XA of X just in case an X that is A is really A. Okay, so that basically roughly tells you if there are A things, then epsilon x A of X picks one of the A things. Okay, and roughly if there aren't A things, whatever you pick won't be A. Okay, so it's very natural that basically you capture logically in your proof theory what I just intuitively conveyed about the epsilon operator. And in an extensional context, you also have an extensionality axioms. Okay, what you pick really only depends on the things that are A, okay? Not how you specify the set of things that are A, okay? And since we want to do extensional semantics, you will also add that in your semantic theory, okay? Now, you might think of the epsilon terms in different ways still. You might think maybe there are some worldly facts of the matters out there, okay? Linguistic facts and non-linguistic facts and meta-semantic laws that ultimately conspire to make it the case that what the epsilon operator picks is uniquely determined again. Okay, so that's something that you find like in a paper by Breckenridge and Magidor, which in many ways is close to what I have in mind. Okay, when they talk about arbitrary reference, that's a bit like what I want to say with my epsilon terms. But they really think that there are facts out there that determine what the epsilon operator picks in my terminology. But I'm not assuming that. Okay, so don't think that ultimately semantic determinacy will enter the picture through the back door. I'm not assuming what the epsilon operator picks is uniquely determined, not at all. The only thing that I'm assuming is the logic of the epsilon terms, okay? And now finally, another way of presenting my Ramsey semantics is this one, okay? I state the following laws, as it were, in my semantics. I suppose that there is at least one admissible interpretation. I leave open whether it's uniquely determined or not, but there's some. Okay, so that's roughly like the Ramsey sentence from before. And now I can explicitly define I to be given by NF such that F is a member of ADM. And I can explicitly define the truth predicate by saying A is true just in case it is satisfied by I, which already had been explicitly defined by using the epsilon operator here. Okay, so ultimately what I get here is very much like what I had on the previous slide. It's just a different presentation of the same idea. Okay, and what's nice about that presentation, that's the reason why I prefer it, I don't have to eliminate symbols like the I and the truth predicate when doing semantics, but I will keep them on board. I can explicitly define them, and yet I will still be able to do Ramsey semantics because I have this epsilon operator, okay? And the only thing that I need to presuppose is that there is an admissible mapping and the logical axioms of the epsilon operator. And thereby I can leave open which of the members of ADM will be picked by the epsilon operator, okay? So ultimately, it helps me to even stay closer to classical semantics because classical semanticists want to use these terms I and true, and I can also do that in Ramsey semantics, okay? But you don't need to think that thereby you buy into the presupposition of a uniquely determined intended interpretation. I do not. I'm only assuming that ADM is a non-empty set, but I do not assume any cardinality assumption about that ADM set, okay? So there are two ways of presenting Ramsey semantics. One just working with the existential quantifier, the other one nicely using these epsilon terms, but both amount to more or less the same thing. And indeed, you know, the good old logical empiricists like Carnap, they used epsilon operators sometimes to, you know, to do Ramsification. Okay, so I'm still on that traditional road, but I use the devices for different purposes. Okay, so that's my package. That's my package now. Okay, now let's see what happens. Okay, now let's compare my Ramsey semantics now with supervaluationism. So what I get in my semantics, but supervaluationism does not. I get in my semantics that truth still is classical, that is, behaves classically. I get classical truth biconditionals. They're derivable now from my semantics. And I get that truth is compositional. So for example, if you look at under which conditions is an atomic sentence like A is P true, well, that's the case if and only if, I still want to say, by my truth definition, the intended interpretation makes true P of A, but really I is explicitly defined as that epsilon term, okay? And if you unpack that, you do that by the semantic rules, which I just copy from classical semantics, and you get that basically what epsilon F is a member of ADM assigns to A is a member of the thing that epsilon F is a member of ADM assigns to P, okay? And you can read that as a T biconditional, as a truth biconditional. What you have here on the right-hand side, you can think of as the meta-linguistic translation of the sentence P of A of the object language. The meta-linguistic translation will use the epsilon term, that's true. Okay, so that's the only difference to classical semantics, but it's still a truth biconditional. That's all. And I'm fine to use epsilon terms in my meta language. Hence, I'm also fine with using epsilon terms in my meta-linguistic translation of object linguistic sentences. And if you look at what you get in my semantics for negation formulas and disjunction formulas and quantified formulas, you get the usual thing because I have the same semantic rules. So truth is compositional. You get what the classical package gave you. Yeah, you can even use the same symbols like true and I. It's just that these symbols have slightly different meanings because they are given sort of by a Ramsey sentence, okay, or they're given by epsilon terms. And if you look at logic, then in my package, logic will be fully classical because the logical consequence relation will be defined as preservation of truth under all assignments, okay? That's the same definition that the classicists have, and automatically all the classical rules and meta rules will remain valid, okay? Even if you threw in a determinately operator into your object language, okay, that would capture supertruth, wouldn't matter, okay? You would get the same classical meta rules to be valid. Okay, so I haven't changed the logic and I haven't changed truth in a sense. Okay, it's just that I didn't presuppose the existence of a uniquely determined intended interpretation. You didn't need that assumption for these consequences. That's why I still get them. Okay, that's why I get the same conclusions as the classical semanticist does. Okay. In fact, this holds more broadly. Ramsey semantics is almost like classical semantics, okay? Ramsey semantics leads deductively to the same predictions as classical semantics, as long as you do not explicitly invoke the assumption of semantic determinacy. And for most purposes, the classical semanticist doesn't rely on it. It relies on it in the background. It's just a presupposition. But for most of the conclusions they want to draw, they don't need that presupposition, okay? And that's why I can save all these things in Ramsey semantics as well. But at the same time, Ramsey semantics is less risky than classical semantics, okay? Because it might be false that there is a uniquely determined intended interpretation. And I do not buy into that. I do not need that presupposition. I do not have it. Classical semantics has it. Okay, I merely presuppose that there exists a classical interpretation, that's the Ramsey sentence, that conforms to all existing meta-semantic constraints and from which truth is defined by the standard semantic rules. That's what I presuppose. Okay, that's also a presupposition, right? You might ask, what if there is no admissible or intended interpretation at all? Then I have a problem. But then notice that classical semantics also has a problem, an even deeper problem, as it were. Okay, and supervaluationism has a problem. Okay, so there is a deeper problem that I won't deal with in my talk here. Okay, but as long as I have the existence statement, that's good enough for me to run and get the nice conclusions. And when there is semantic determinacy, okay, when it just happens, as it happens, you know, we are lucky. Everything conspires in the right way, and ADM is a singleton set for an object language. Okay, could be. Then my Ramsey semantics will just collapse into classical semantics. Okay, so the I that my epsilon operator picks will be the uniquely determined I. Okay, by the laws of the epsilon operator. Okay, and the truth predicate will just be the classical one, and I get classical semantics out of my Ramsey semantics. But I allow for semantic indeterminacy where classical semantics does not. That's the point why I'm, you know, my approach is less risky. Okay, so let's have a look at what happens in my 3 example cases. So take vagueness. Okay, so here are things that I can derive in my meta theory. Okay, by having the Ramsey sentence and the explicit definition of I and true by the epsilon operator definitions. Okay, for example, say in my meta theory, I can derive something about ADM, namely, if M counts as a case of baldness and M is more hair than N, then N also counts as a case of baldness, right? So say 3 hairs, okay, counts baldness, then also 2 hairs, okay? So this is what Kit Fine would have called the penumbral connection, okay? And it sounds very plausible indeed. So that's a law that I think everyone wants to buy into, okay? So say this is the case. That's something that we have that is true about ADM, and we can state it and maybe derive it in our meta theory, okay? Now, when you add now Ramsey semantics, okay, what you can derive is for all Mn, if M is greater than N, and bald of M is true, then bald of N is true, okay? So actually, you know, this is a bit sloppy here, okay? So I hope you trust me that we could unpack that in the right way. So really, you should rather use a satisfaction predicate here, okay, than the truth predicate, because otherwise you're quantifying into quotational context. But all of that can be repaired, okay, by Quine corners or other devices, okay? So this is something that we want to buy into, and I can buy into it. I derive it in Ramsey semantics, and supervaluationist semantics would also derive it, okay? Since we have that, we would also get that. If bald M is true, then bald M must be true, because M number of hair is greater than N number of hair, and from that law, we get that law. Okay, so that's fine. No, not a big deal. Okay, if 2 is bald is true, 1 is bald is true. Okay. However, here's the thing. In my Ramsey semantics, bald M is true. If you look at that part, will be equivalent to not bald of M being not true. Okay. So the equivalence of bald M being true to not bald of M being not true, I will be able to derive in my Ramsey semantics. Okay, so I will be able to replace that by that, and just in Ramsey semantics, you get for all Mn, if N is greater than N, if not bald M is not true, then bald N is true. Just by that equivalence here. I get that, as you would in classical semantics, by the way, yeah? Supervaluationism doesn't get you that, because not M being not true is not equivalent to bald M being true in supervaluationism. Why? Because truth is supertruth, and you don't get that equivalence for supertruth. Okay, so there is something that I can derive now that I intuitively we would have thought in classical semantics is right. I can derive it supervaluationism can't. Okay, so that's a typical case of things that you can derive about vague terms in my semantics that it's nice to derive pre-theoretically. Okay, if you look at the famous Psoriatis argument, okay, for baldness, so 0 hair is a case of baldness. If N number of hair is a case of baldness, then also N plus 1. Therefore, having 100,000 hair on your scalp is a case of baldness, okay? That's a logically valid argument in classical logic. Ramsey semantics accepts classical logic, you get classical consequence, so it's still logically valid, okay? The first premise is true, the conclusion is false, okay? That you get about assumptions about ADM that I think are super plausible and that you would state in your semantics too. So the culprit, the problem case must be premise 2. It must not it's not true in Ramsey semantics. Okay, so as a Ramsey semanticist, the diagnosis about the Psoriatis argument is the second premise, the major premise, is false. Okay, so far so good. Yeah. Now, what does that mean? For all n, if n bold, then n plus 1 is bold. If that's false, this is equivalent to saying there is an n such that n is bold and n plus 1 here is not bold. Okay, it's true. That statement must be true because you get that in Ramsey semantics. Okay, quantification is just standard quantifications. You get the standard rules, standard semantic rules in Ramsey semantics as you do in classical semantics. Okay, and in fact, every f in your set of admissible or intended interpretations will satisfy that existential claim. That is, it will even be determinately the case that there is an n such that n is bold and n plus 1 is not bold. That statement with the determinately operator, as it were, determinately now expressing that something is true at all admissible interpretations, that determinately statement will be true if you have the determinately operator in the object language. Okay? So here's the thing. Isn't that bad? Okay? Doesn't Ramsey semantics now derive that there is sort of a sharp distinction between boldness and non-boldness? Okay? And isn't there now a sharp boundary for boldness, which sounds odd because there should be these blurry cases. There should be a blurry boundary, okay, for bold. So isn't there a problem now that we have in Ramsey semantics, okay? And now I want to argue in some sense we do not have a problem, okay? So if you thought that Ramsey semantics was committed to sharp boundaries in the sense that there is an n such that it is determinate that n is bold but n plus 1 is not bold, if you thought that is a sharp boundary, then don't worry, Ramsey semantics is not committed to that statement. In Ramsey semantics, you can't derive that there is an n of which it is true that it is determinate that n counts as bold and n plus 1 is not bold. Okay, you do not get that. So Ramsey semantics is not committed to a determinate sharp boundary. It's not that the facts determine a sharp boundary. That's not the case in Ramsey semantics. Okay, the only thing that Ramsey semantics is committed to is it is determinate that there exists an n such that n is bold and n plus 1 is not bold. Okay, and that is something that is true because this existential statement is true for every interpretation mapping in ADM, and all of these interpretation mappings are classical, so automatically you get that. Okay, in other words, the determinately operator that I can still use in Ramsey semantics, like you can use it in supervaluationist semantics, okay, it doesn't commute with the existential quantifier. Okay, so you get this, but I want to say that's fine. I'm not worried about it, but you do not get that, and it's that people have in mind when they think that sharp boundaries are a bad thing. Okay, in some sense. Okay, you can also still say that bold has a unique, okay, with scare quotes, intended interpretation. If by that you mean there is a unique x such that x is identical to I of bold. That's fine. That's a trivial law that I can derive in Ramsey semantics because that's a singular term, and you get that generally in classical logic. Okay, and in the logic of my meta theory is classical. Okay. That's fine, don't worry about it. But don't think this means that there is a factually uniquely determined interpretation in the sense that there is a uniquely determined member of ADM. That's not the case. I'm not assuming that. Okay? So with all these very cases, sharp boundaries, unique intended interpretation, you need to unpack what you mean by that. Do you mean that this is determined by the facts? Then don't worry, you don't get that. Or you just mean something that basically you almost get by logic. That's fine, but don't worry about it. Okay, that's what I'm saying in Ramsey semantics. So in a nutshell, you could say classical semantics assumes the borderline facts for boldness, for example, to be complete. You can derive that there is an n such that it is determinate that n is bold and n plus 1 is not bold because there is a uniquely determined intended interpretation. Okay, so classical semanticists would say the facts are complete. Okay, there's just one way of spelling out correctness for boldness. And the concept of truth is, of course, a classical Tarskian one. Supervaluationist semantics does not assume the borderline facts to be complete. You can't derive there is an n such that it's determinate that n is bold and n plus 1 is not bold. Okay, they do not assume that there is a uniquely determined intended interpretation. But supervaluationist semantics changed the concept of truth. They invoke a non-classical concept of truth, super truth. Okay. And Ramsey semantics is different from both of them. Like supervaluationist semantics, Ramsey semantics does not assume the borderline facts to be complete. You do not get that existentially quantified statement. Okay, there may well be more than one intended interpretation. So that's what I have in common with supervaluationism. But what I have in common with classical semantics is that my concept of truth is still a classical one. It's given by the Tarskian clauses, okay, being defined by means of an epsilon operator, of course, from ADM. Okay, so what I get is, I want to say, hopefully, okay, I get the best of both worlds. Yeah, I like supervaluationism. I do not need to buy into semantic determinacy, which is good. But like classical semantics, I can keep a classical concept of truth, which again, I think is good. Okay, because I think truth pre-theoretically is much closer to Tarskian truth than it is to super-truth. Okay, but what that means is that is meta-semantically determined, okay, may differ in extension from the predicate true. Okay, so what is meta-semantically determined is not the same thing as what is true. Semantics may outrun the facts, as it were. So that's something that you have to live with when you buy into Ramsey semantics. But for me, it's fine. We can still talk as if the meta-semantic facts had determined a unique interpretation. We can still use the symbol I, even though in the background we know it's defined by an epsilon term. Okay. And by the way, you can also deal with, in similar ways, with higher order vagueness if there is such. Okay. So if there is higher order vagueness, maybe the term ADM that I used, maybe that is itself vague and hence semantically indeterminate, then yes, you can spell it out, and you would do that by looking now not at the meta language, but at the meta language, and specifying there a semantics for what was now the meta language. And in that meta language, that semantics for the meta language, I would again use, a Ramsey sentence, epsilon terms, and the same machinery would be put to use. So basically, I would use the same machinery throughout the whole Tarskian hierarchy. Okay, so it might well be that there is indeterminate terms throughout the hierarchy, and if so, you would use Ramsey semantics throughout the hierarchy. Okay, so that's the idea. Now let's look at my arithmetical case. Okay, so there, let's assume you're a structuralist. Okay, so the set ADM is consisting of the set of all interpretation mappings that satisfy the second order Dedekind piano axioms. Everything that gets the structure right. Okay. Now we do not need to assume the Ramsey sentence because, in the meta theory, we have set theory around, then we get for free that there is at least one admissible mapping. Okay, you can prove that from set theory. And now Ramsey semantics would add to this the definition of the I term for the scare quotes intended interpretation by the epsilon term and the definition of truth by I. Okay. And then in Ramsey semantics, you could derive, for example, that PA2, okay, so the Dedekind piano axioms are true just in case there is an F that is a member of the set ADM, okay? And since set theory gives us that, you can derive now in the whole package with set theory on board that P of A is true. And of course, that's what we would think pre-theoretically anyway. Okay, but even if you didn't get the Ramsey sentence from set theory, okay, forget about the Ramsey sentence for the moment, you would just get this conclusion here from these two assumptions by the logic of the epsilon terms. Okay, so basically the truth of arithmetic is equivalent to, as it were, the satisfiability of arithmetic. Namely, there is an F that is an admissible mapping where this is the set of admissible mappings here. Okay, so by that package, my Ramsey semantics predicts that arithmetical truth is in some sense nothing else than the satisfiability of the arithmetical axioms. Okay, and this might ring a bell. This sounds, familiar if you're interested in people like David Hilbert, who once argued in his letters against Frege and others that truth in mathematics is really consistency, as it were. Okay. Now, you do not get consistency, strictly speaking, as a syntactic notion, but you get satisfiability as a kind of model-theoretic notion. I find that a very plausible conclusion, and you get it from Ramsey semantics. And you can deal with the fact that there is more than one F in that set here. That's not a problem at all, okay? And you can still do something like classical semantics for arithmetic, but you do not need to buy into semantic determinacy. And with this conceptual progress example that Hartree Field looked at, the Newtonian mass example, you can assume now that ADM consists of two mappings the one admissible mapping maps the mass term to relativistic mass, the other one to proper mass. Okay, they are distinct. So you have two mappings in ADM. Okay, you have that there is something in ADM. That's the Ramsey sentence, so that's fine. And then you get, the epsilon term definition of I and then of truth. And then what you can derive in Ramsey semantics is that I of mass, again, scare quotes, the intended interpretation of mass, is either identical to I1 of mass or it's identical to I2 of mass. You can derive in Ramsey semantic that disjunction without deriving either of the disjuncts. Okay, so if this is what you have, you won't be able to derive the one disjunct, you won't be able to derive the other disjunct, but you're able to derive the disjunction. So your semantics leaves open, which of them is the right one, because there is no fact of the matter. So again, you can derive what intuitively people like Hartwig Field argued is right. You can derive exactly what is there, what the facts sort of tell you and not more. Okay, so again, I think that's good, and you tick the box, as it were. You can do more. I can't go into details now. For example, say you wanted to say you're a realist, a scientific realist, okay? And you want to just say there's a lot of continuity between old science and new science, okay? Then it's consistent with my approach, with my Ramsey semantics, that you add, for example, that what the epsilon term picks with respect to the admissible intended interpretation of the old scientific language is identical to what your epsilon operator picks with respect to the intended or admissible interpretations of your new, maybe, language of relativistic physics, okay? So you can stipulate, because you're a scientific realist, that there is a lot of semantic continuity between an old language and a new one, okay? This identity statement is nothing that is derivable from Ramsey semantics for the old language and Ramsey semantics for the new language. So you don't get that for free, but you can stipulate it, and it's consistent with Ramsey semantics. That's what I'm saying. So if you want to be a realist, a scientific realist about concept change in science, you can be. Don't think that Ramsey semantics excludes you. Okay, it can embrace your viewpoint, and by stipulating an identity claim like that, okay, you can always do that consistently as long as the set of admissible interpretation for the old scientific language has a non-empty intersection, a non-empty overlap with the set of admissible interpretations for the new language. As long as this is the case, it's consistent to be a scientific realist, even if you want to do Ramsey semantics. Okay, it's consistent to understand terms from two languages as if the meta-semantic facts had determined their reference to be the same. But it's just that Ramsey semantics doesn't presuppose it's the facts that do the job. You have to do it as a semanticist, as it were. But you're free to do that. It's consistent. If you're an anti-realist, you want to say there is these changes around, that's also consistent with Ramsey semantics. Ramsey semantics by itself doesn't tell you whether you should be a realist or an anti-realist in that case. Okay? And there is a nice historical background to what I'm doing here. So famously, and I mentioned that briefly before, Rudolf Carnap already suggested to define scientific theoretical terms with the help of epsilon terms. Okay? In his case, he wanted to do general philosophy of science, not semantics in that case. Okay, I want to do semantics, but it's the same idea. Okay, so as Carnap said back then, say we define theoretical terms by epsilon terms. Okay, then this definition gives us just so much specification as we can give and not more. We do not want to give more because the meaning should be left unspecified in some respect, because otherwise the physicist could not, as he wants to, add tomorrow more and more postulates and thereby make the meaning of this term that we're interested in more specific than it is today. Okay, so the idea that he has is, say we use temperature as a theoretical term, okay? And now we specify the meaning of temperature by some postulates, okay? Maybe some postulates that relate the term to, ways of determining temperature experimentally, okay? So this is now, okay, 1900. Now in 1910, the physicists have already specified the term temperature by further laws, okay, further ways of determining temperature. They've just added them to the old ones. Then Carnap wants to say they have specified the meaning of the term temperature in more ways. They've been more specific now about the term than they have been previously, okay? And that's good. So Carnap wants to say scientific terms, their meaning is open-ended. Is open to extension, okay? They can be narrowed down in the course of scientific progress, okay? There's not just progress with respect to what we find to be true, there's also conceptual progress, and that's, for example, specified by these getting more and more specifics right about the terms of science, okay? Narrowing down extensions. And he wants to say now, okay, how can we reconstruct that as a good philosopher of science? He says, well, the epsilon term reconstruction of theoretical terms does the job, okay? So in the first case, I have an epsilon term, 1900. In the second case, 1910, I have another epsilon term where, you know, more clauses would be in the body clause of the epsilon term, okay? And the epsilon term is exactly the tailor-made tool that we needed. You get an explicit definition of the theoretical term, but since the epsilon term doesn't pin down meaning completely, it leaves something open, okay? We capture the open-endedness, the indeterminacy of the scientific terms, and that's just for him a scientific fact, a fact about scientific practice out there. Okay, and he gives this example: you can derive a disjunction now without deriving either of the disjuncts, like I had on the previous slide. Okay, so he already used epsilon terms. My only innovation I want to argue in my talk is that I use these epsilon terms now to Ramsify away theoretical terms in semantics, namely intended interpretation and truth, and you get the same fruits. Okay, that's the idea. Okay, just as he argued, the Ramsified theory, okay, will preserve everything that's important. In some sense, I argue now, everything that was important about classical semantics is saved by my Ramsey semantics, okay? And we don't need to buy into semantic determinacy. Okay, so let me end. I hope I've given you a good argument that if one wants to be prepared for semantic indeterminacy, so that's different from epistemicism, they're not prepared. They need to presuppose semantic determinacy. If you want to be prepared, at least, for semantic indeterminacy, and if you also want to stay close to classical semantics, and in fact closer to classical semantics than supervaluationism, okay, so you want to get the logic right and truth should be classical. If you want that package, be prepared for semantic indeterminacy and stay close as possible to classical semantics, then Ramsifying classical semantics, Ramsey semantics will be the package for you. Okay, that's all. And I hope if you're an anti-realist maybe about semantics, you know, something about that package might even appeal to you, okay? So for example, intuitionists have always complained that in order for A or not A to be true, it seems that the fact would either have to determine A or the facts would have to determine it to be true that not A, but maybe we don't have enough facts to do that, hence we shouldn't buy into classical logic, and you know, off goes the intuitionistic train of thought. Okay, but for example, if you interpret mathematical languages by Ramsey semantics, you can get classical logic, you can get classical mathematics out as you want it. You don't need to change logic and mathematics as the intuitionists did, but you do not need to assume either that the facts either need to make it the case that A is true, or the facts need to make it the case that not A is true, because truth may outrun the facts, as I said before. Okay, so there is something in my package that might even appeal to the anti-realist about semantics. Okay, and if you want to use Ramsey semantics to understand scientific language and language change, you can still be a realist and yet use Ramsey semantics. Okay, my Ramsey semantics doesn't come and doesn't presuppose strong scientific or metaphysical assumptions. You know, you don't need to assume semantic determinacy about scientific theory change. Okay, and I think that's good. And yet you can talk as if you were a scientific realist. Okay, so that's the package that I wanted to argue for. So initially we had this tension here, and I wanted to show that I release the tension. Basically, I give up that presupposition, no unique intended interpretation. I don't need that. Okay, and still, what was successful about classical semantics, I was able to save. Okay, and this is perfectly compatible with assuming or believing or finding it likely that for many fragments of natural, mathematical, and scientific language, there is no uniquely determined intended interpretation. Okay, and that's what I wanted to show. Thank you very much.
Okay, thank Professor Hanus Leitgeb for this very wonderful and insightful and great lecture. And yeah, we first thank the speaker. Yeah. So also you can see that the research on semantic indeterminacy is very important and could have many applications. Okay, now the rest is our question and answer section. Okay, for the audience, please just take your time to input your question in the chat box, and the staff will forward your question to us. Okay, firstly, I see that there's a question from Professor Wang Wenfang. I'm not sure whether every audience can see this question. So let me first read this question. Okay, person one asks that he comments that Ramsifying semantics is similar to supervaluationism in having the problem of missing witness. Is that a good result?
Good question. But
I also have an elaboration about my question. So maybe say Professor Cheng should also say just say the elaboration I gave. Yeah.
Mm-hmm. Do you want to read that, Yong?
That's okay. Okay.
Yeah. Go ahead.
So, person one, you want to me ask the question to Professor Lalibey, or you
I just hope that you can also read the other paragraph that I wrote. Yeah.
Oh, okay. So to elaborate Professor Wang's questions, he thinks it's good to have it true that determinately some number is the cutoff point between being bold and being not bold, and being not bold, without having it true that some number is determinately that number. Still, it stands against our intuition to have it true that some number is the cutoff point with any particular number being that cutoff point.
Sorry, I have a typo there. So it's still say against our intuition to say that, well, some number is the cutoff point without having any particular number to be that cutoff point.
Yes. Well, in some sense, I agree, and it's a very good point. And let me put it like this. So there's the Psoriatis paradox, right? And the reason it's a paradox is that all the premises sound initially plausible, right? And the conclusion is absurd. It's logically valid. So what can we do? So there is, I want to say there's always a problem. Right? Whatever you're going to do, okay, there's always some repairing work that needs to be done. Okay. So everyone has their burden to carry. And what you point your finger on is exactly the burden. So what I said is, right, if you thought that there are sharp boundaries, right, and you think Ramsey Semantics is committed to that, okay, don't think that I'm committed to sharp boundaries in the sense that there is an n such that it is determinate, blah, 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 right? And that's good because I'm not committed to that. Yeah? What you are saying is, look, but you're still committed to it is determinate there is an n, right? It's sort of another version of sharp boundaries. And isn't it odd, intuitively implausible, or tension still, that you are committed to that? And I have to agree that is true, okay? But maybe what makes this one version that you worry about, right? It is determinate there is an n. So worrisome ultimately is that intuitively we think that is equivalent to the other version. Maybe intuitively, pre-theoretically, we think that determinately commutes with the accidental quantifier, but it does not, okay? So for me, determinately there is blah, 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 really is equivalent to saying the interpretation mappings in my set ADM are classical. And truth relative to any of them is defined classically. And that's a package that I want to keep on board. So I want to have that ADM is a set of classical interpretation mappings. I want to keep that in classical semantics because I think it's important. So, for example, if you think the way out of the Psoriatis is to go to a non-classical logic, right, many-valued or whatever, it's something that you want to change here, but I don't want to do that. I want to stay close to classical semantics here, okay? So that's nothing that I want to give up. And I also want to understand truth as being given by interpretation mappings in the classical way, okay? So since for me, you're basically worrying, Hanus, don't you worry that all your interpretation mappings are classical and truth is classical for each of them? I want to say, no, that's exactly what I want. I'm not worrying, okay? But the statement, I admit, at least initially sounds intuitively problematic, okay? I hope the problem really comes by an intuitive equivalence with another statement that I don't get. Okay, here basically what I'm saying, by the way, is not new. So McGee and McLaughlin, they had these very nice papers, right, that are partially supervaluationist and partially they use a deflationary, a disputationalist truth predicate and combine them. They have similar claims to make here. So I'm really relying on their work. The difference is they do not use Ramsification, okay? So for me, they never clarify in the right way how the disputationalist truth predicate interacts with supervaluationist truth, because they have both. In my Ramsey semantic package, truth is just truth. It's classical. It's Tarskian. Okay? There is no supertruth. You can have a determinately operator, and you can use it, and it's useful if you want to say what a vague term is, for example, and so on. Okay? And there I want to make similar claims like they make and use similar defenses. Okay? But I have a nice story that relates ADM, as it were, to truth, and that's the Ramsification story. So for me, that was always the missing bit in their story. But otherwise, what I'm saying will be just as convincing or unconvincing to you than as what they were saying. And you're absolutely right. It's not totally appealing, but I hope we've at least pushed the problem to the right place. Okay. Thank you.
Can I ask more question? Yeah.
Yeah, please. Yeah.
Okay. I have two more questions for Professor Leitgeb. So the first one is this. So your theory doesn't look like, supervaluationism to me, but it looks very similar to, subvaluationism, except that so far I can see is that maybe you define the truth of a negation or the falsity of a sentence in a different ways. So that in subvaluationism, they can have a sentence for true and false, but in Ramsifying semantics, you will not have this result. But is it possible that we revise the subvaluationism in a little bit, according to your way to define the negation, the truth of the negation or the falsity of a sentence, so that, the subvaluationism will have the same benefit as the Ramsifying theory, semantics? That's my first question. Yeah, the second
let me answer that question first, and then let's move on to our second question. Okay.
All right.
So about this, so I see why initially you might think they are similar, but they are not, and the differences are bigger than they define negation differently than I do, or so. So that's what I briefly hinted at when I said. My existential quantifier is not in the scope of the truth definition, but it's outside of it. So it's a bit like de re and de dicto. Okay? So the subvaluationism is a little bit like, I believe that there are spies. Okay? Whereas my Ramsey semantics is a bit like, there is an X of which I believe that he or she is a spy. And like de re and de dicto are not the same, subvaluationism and Ramsey semantics are not the same. So my existential quantifier, there is an admissible mapping, is outside of the scope of the definition of truth. Okay? And this has an effect. So for example, for a subvaluationist, truth is still not compositional. Just as truth for supervaluationists is not compositional. Okay? The difference is for the one, you use the universal quantifier to define supertruth, and for them, they use the existential quantifier to define subtruth, but in neither of the cases, you get compositionality, whereas I do, okay? The supervaluationists, they will have gaps, right? So some sentences are neither supertrue, nor are their negations supertrue, okay? The subvaluationist will have gluts, as it were, right? Some sentences will be subtrue, and their negations will also be subtrue. Okay. Now, Ramsey semantics will be different for both of them. For Ramsey semantics, you're guaranteed to neither get gaps nor to get gluts. Okay. For every sentence, either the sentence is true or the negation is true, but not both. Okay. So you don't get a gap, but you also don't get a glut. It's not possible that A is true and also not A is true. That just won't happen in my Ramsey semantics, okay? Yes. So there you can see the differences to subvaluationism. It's not subvaluationism, it works differently.
All right, okay. So maybe I misunderstand some part of your semantics. But anyway, so you are proposing that, maybe we should allow, more than one intended interpretation, right? Have you ever considered about any restriction about a set of intended interpretation? I mean that you can't just allow any set to be the intended interpretation, right? There should be some restriction on, what an intended interpretation can be. So have you ever thought about that? Yeah.
Yes, absolutely. So think of my second example, the case of arithmetic, right? There I said ADM
is the set of interpretation mappings that satisfy the Dedekind-Peano axioms. Not every interpretation mapping of the language of arithmetic is in that set, right? There are many logically possible, as it were, interpretation mappings that wouldn't give you the Dedekind-Peano axioms. I want to say the set of intended or admissible interpretations for arithmetic are those that get the structure of the natural numbers right. So that's a restriction. You're absolutely right. And that's the restriction in that case, right? Look at my third example. So this was about how to interpret mass in Newtonian mechanics, right? There I said ADM consists of two interpretation mappings. One understands mass in Newtonian mechanics in this relativistic way and the other one in the proper way. Okay, and that's it. There would be logically possible, as it were, other interpretation mappings, but it's just two of them if Hartree Field is right. Okay, so ADM is very restrictive, and in each case the reasons are different. Okay, in the arithmetical case, you would look how the mathematicians are using their arithmetical terms, and you get this idea: oh, for them only the structure counts. In the other case, you look how Newton used the term mass. From the modern point of view, he must have meant either this or that, and that's all. All the other interpretations would get too much wrong about what he thought. Okay, so that's the Fieldian argument. Just one sentence. Okay? And in the first case, with the vague terms, it's really you would go there and look how people use terms like bald and heap and so on, and you find, well, look, there is constraints. Like, as I said, 0 counts as bald. You will find it everywhere, right? Whoever is the person who uses the term bald, right? And 100,000 counts as not bald. These are facts, as it were. But there will be cases where people use the term bald in different ways, and these different ways will be equally fine with all of our linguistic rules. They will be good English speakers still. And you capture that by assuming that there is more than one admissible interpretation. In general, however, it will be difficult to unpack what ADM is like, okay? Because, basically the meta-semantic laws are really tricky business. That's the whole business of pragmatics and so on and so forth, okay? We know something about it, we lack other knowledge, okay? What I find nice, I hope, about my approach is I presuppose this set ADM, and that's all, okay? I'm not presupposing, I'm not telling you I know a complete description of ADM that I could give you, okay? Basically, I have a kind of theory, as it were, in the background, but a theory in the sense of the non-statement account of theories, right? It's a set of models, as it were, a set of interpretations, ADM, okay? It's not the idea that I can already give you the full theory of how ADM is specified. I've just hinted at that. I can say a bit more, but I won't have the full details, and that's just it.
So can I just say that your restriction is just similar to Kip-Fine's admissibility? Yeah.
Yes, absolutely. Absolutely.
Okay.
It's the same idea.
All right. Okay. Thank you.
Thank you.
Okay. I don't say any question, okay, from the stop. Okay.
Maybe, Yong, if I may, because I'm still feeling that this difference to subvaluationism hasn't become fully clear. So can I go back to that quickly? Yeah.
Yeah. Oh, sure. Okay. Please.
Yeah. If that's okay, because I had the feeling there's still a question open. Okay. I could see it in your eyes. Okay. So the idea.
I just shut off my screen.
Yes. So. This is the thing. So basically, I say, this is what I postulate as the Ramsey Semantics, okay? There is a member F, an interpretation mapping in ADM, such that truth is defined by it. That's what I claim, okay? Whereas the subvaluationists would say, A is true just in case there is an F in ADM that satisfies A. So they say true, and then there is an F, whereas I say there is an F such that true, blah, blah, blah. That's this difference in scope of that. Okay? So there is an interpretation mapping. It's admissible. Okay? And it defines truth. I leave open which of them is the right one, because the facts don't tell me anyway. They're all on par. But I just say I pick one of them. That's what the epsilon term here does, okay? The epsilon term picks one of them, okay? And then I define truth from it. Whereas the subvaluationist defines truth, A is true just in case there is an F such that F satisfies A. And that's not what I have, and they are not equivalent. Okay, and then this has these consequences that, for some sentences they have that it's subtrue and the negation is subtrue, but for me that won't happen, and so on. So ultimately, in my way of doing it, I stay much closer to classical semantics than subvaluationism does. Okay, so I hope that this helps a little bit. Yeah.
Okay, Professor. Yeah, just for your last slide. Yeah, this definition is clear for us. But for example, according to this definition, if we judge whether a given specific sentence is true, then the problem for me that how do we know what is that element picked up by the epsilon operator? Yeah.
So the only thing, as it were, right, that we know about is the set ADM. So generally speaking, there is something that we know about ADM. Like I said, whatever F you pick in ADM, right, 0 here, according to F, will count as bold. That's something that we know about ADM, or if you like, about all the members of ADM. Okay? Which interpretation mapping within ADM is picked by the epsilon operator is not anything that we can know. And the reason is there is no fact of the matter about it. So it's not that there is a fact, the world really says it's that thing, okay? And we just, we're a bit stupid, or we are limited beings or whatever. We can't find out which one is picked. There is no fact of the matter what is picked by the epsilon term. Okay, that is what I want to say in Ramsey Semantics. Okay, now you might say in some cases, who knows? So maybe we are super lucky, right? For boldness, the facts out there are so vast that really there is a uniquely determined intended interpretation that could happen. Then ADM consists of one mapping. ADM is a singleton set, in which case my Ramsey semantics would be such that the epsilon operator must pick that member because it's the only member. In which case, my Ramsey semantics will have the same predictions as the, epistemicist classical semantics. There won't be a change. But if there is more than one intended interpretation, and for me that's likely for boldness, and yeah. But who knows? Okay, if there is more than one, then Ramsey semantics is such that we have something about ADM that we know. You can write it down in your meta theory. You can derive conclusions if you add the semantic rules of Ramsey semantics. That's all fine. But you will never be able to know which one is picked by the epsilon term because, there's more than one. And the epsilon operator, there's no facts of the matter what it picks. And that's good. So in some sense, I do not want to eliminate the semantic indeterminacy that you find in the object language. I want to preserve that. Think of Carnap. It's good for some purposes that there is openness in our language, okay? I just want to make things a bit clearer, a bit more precise, okay? I want to write down semantic laws from which I can derive interesting semantic consequences. That's what I'm doing. And the epsilon operator is just a formal symbol that gives me clarity and precision, but it also preserves the indeterminacy of the object language. And I like that.
Mm-hmm. Okay, thank you. In your slide, your definition of the Ramsey semantic, it seems that you missed the definition of that the existential sentence is true. So for that, for example, the x, fx is true. So that it means that we can pick an interpretation from the set or the admissible interpretation, and then quantify over in the domain of this pick out interpretation. Is that right?
I didn't completely understand the question, Yong. Can you say it again? Sorry. Yeah.
I mean, in your slide about Ramsifying semantic,
yes,
you tell us what means that if satisfy arithmetical formula and satisfy negation and disjunction. It seems that the extensor formula or universal formula is missing in your slide.
Oh! I see what you mean. Okay, but that's easy to sort out. So what you're saying is, when I presented here, I didn't have the semantic rules for the quantifiers. Is that what you're saying?
Yeah.
Yeah, not dot here. They are there. Don't worry. I'm fully classical. So for example, one thing that Ramsey Semantics has is f satisfies for all x p of x, if and only if, okay, for all objects little d in the universe of discourse, okay, f dx satisfies p of x, where f dx is like f except assigning d to the variable x. So I have the standard classical semantic rules for universally quantified sentences. And I have the standard classical rules for existentially quantified sentences. I just didn't put them here because I thought you're fine with me if I say I take for granted all the classical semantic rules. I just have them. Don't worry, they are there.
Okay. So it's similar, just some many sort of interpretation, just semantic, similar as the many sorted first order logic.
No. Sorry, we are still talking past each other, Yong. So what I suggest, you can do it for a one-sorted language, you can do it for a many-sorted language. Why would you think it's many-sorted? So I still don't understand what you're asking. Sorry. Is it because here I define truth just for sentences? Is that what you're asking? Sorry, I'm still lost. What do you mean?
Anyway, maybe I misunderstood what you're saying. I just talk about how to interpret the quantifier. So
yes,
you have more than one interpretation, and each interpretation you have a domain. So when we interpret this quantifier, you just first pick out some interpretation, and then you quantify over the domain of that interpretation pick out, right?
Yes, that's right.
Okay.
Yes, that's right.
Okay, I see. Yeah. Okay.
No, the idea is that every interpretation mapping in ADM comes with its domain. So for me, an interpretation mapping is not just an assignment to the descriptive terms of the vocabulary, but it also comes with a domain. So it's the universe of discourse of F. Okay. So what Ramsey Semantics then does is the epsilon term picks an admissible mapping. Yeah, that admissible mapping that is picked comes with its universe of discourse, with its domain, and then truth, according to that definition, if A is universally quantified, does then interpret the universal quantifier as ranging over the domain of the interpretation mapping F that was picked.
Okay.
Does that answer the question?
Yeah. Now I'm clear about what was this what's the meaning of the quantifier? Okay.
Thank you.
Okay.
Can I ask a question too?
Yeah. Yeah. Please. Yeah.
Thank you very much for the talk. And
thank you.
This is a kind of clarificatory question, actually. So, can we say that with this approach, indeterminacy is moved at the meta-semantic level, in the sense that it is not determined what the intended interpretation is? Or perhaps you would say that you prefer a structuralist view of semantics, in the sense that you take what is in common among the various intended semantics?
I'm not sure I would call my semantic structuralist necessarily. Maybe you could call it like that. I mean, it's certainly a non-statement view in a sense that I'm using. So maybe in that sense it's structuralist, but not in any deeper sense. But it's the case. You spelled it out. You move up or so. For me, it was always there. So for me, where does semantic determinacy or indeterminacy come from? Always from the facts that are to do with usage of terms, and then, some additional world effects and laws, as it were. Okay? So, basically, why are the arithmetical terms indeterminate? Because number theory only cares about structure of the natural numbers. That's where the indeterminacy comes from in that case. Okay? In the case of bald, that term, it's to do with how ordinary people in ordinary context use the term bald, okay? And that there are borderline cases. The laws there are harder to write down, but it's always that the indeterminacy comes from, facts about usage of language and how we relate to the world in a sense, okay? So in some sense, these gaps are always meta-semantic from the start, okay? Now, on what my semantics adds to that, it doesn't add any additional gaps. If there are gaps, it comes from there, as it were. And I think that's what you were saying, and that's exactly right. Okay, and that's I would say it's you could have a semantics that sort of adds gaps where the world didn't have any. That's not what my semantics is doing. Okay, in some sense, you could even think of my semantics as filling gaps, right? Because in my case, right, for every sentence, either the sentence is true or the negation of the sentence is true, right? So there is no gap there, even though, right, the world might not be kind enough for us to make one of them true, sort of by worldly facts, okay? So that's what I meant when I said truth outruns the facts, okay? So in some sense, my semantics even closes gaps where the world has it. But when there are gaps, they will always come from the world, as it were. Yeah.
Thank you.
I have one final clarifying question, if I can ask.
Yeah, please. Yeah.
Okay, so I don't quite understand, say, the epsilon operator. When you read it informally as, say, an X such that A, well, I can imagine it's just a longer way to say an A, right? But if that's true, say, I don't see why we should hold the extensionality principle for the epsilon. Because the intentionality principle would say that, well, if A and B are equivalent, then say whatever is an A will be identical with, well, an A will be identical with an B, which is not true, right?
That depends, really. That depends. So in my case, right, what extensionality means is I only care what the set ADM is like. I do not care how you've specified ADM. Okay, so think of Kit Fine, right? He had this set of admissible interpretations, right? The possible sharpenings or so, okay? That conform still to the way how we use the terms. For me, it's just important that the set is determined. And once the set is determined, the epsilon operator will pick one member. If you describe the set in one way or in another way, as long as it's the same set, the epsilon operator will pick the same function.
Okay.
And as far as I can see, nothing bad can be derivable from that additional assumption. Okay, so that's why I'm buying into it. Okay, if you didn't want that, then basically you make your semantics in some sense less extensional. Maybe but that's fine. Maybe you do not want to use standard set theory in your semantics, but do it a bit differently. Then maybe you keep the epsilon terms, you keep the Ramsification, you just drop the extensionality axiom, because maybe you want to give an intentional semantics for an intentional language, and you think it's important how ADM is specified or so. And then you're free to do so. I still think it would be a Ramsey semantics. That would be fine with me. But for my extensional, as classical as possible semantics for an extensional language, it seemed that extensionality about the epsilon operator was a natural assumption. Because for me, it's just important what that set of admissible functions is like, not how you describe it. That's it.
Okay. Yeah.
Okay, thank you. So yeah, so you talk about the Vagueness paradox. So you think that this Ramsey semantics can be applied for the analysis for many semantic paradoxes, right?
That's an excellent question, Yong. So I've written a paper, and at the very end, in the conclusion section, I say a little bit about possible extensions of the theory, additional applications that I don't deal with in my paper itself. And one application that you might think of would be not to the Psoriatis, but say to the liar paradox. Yes, to the semantic paradoxes. That's what you had in mind, right?
Yeah.
Yeah. And I think that's, as far as I can see, a possible application. So one way of dealing with the liar paradox is supervaluationism again, right? So something that Andrea Cantini worked out proof theoretically, and other people worked about semantically. So the idea is that you have a type-free language with a type-free truth predicate, right? You have a Kripkean hierarchy with a jump operator, and the fixed point under that jump operator will be a set of classical interpretations of that language with a type-free truth predicate. And then people would say you define truth, as it were, as truth under all interpretations there or so. Okay, so that's one way of doing it. Another way would be apply Ramsey semantics. Okay, And it's nothing that I dealt with in my paper. It's something that I would be very much interested in seeing. And I don't think it has worked out. People have worked it out in detail. But maybe something interesting would come out of it. So it would be nice if people were looking into that. I didn't do it myself, but it's a very nice idea.
Okay. So thank you very much for the lecture. Yeah. It's interesting for me that what is the meaning of incompleteness theorem in the view of the Ramsey Semantic? Anyway, I would like to think about it. Okay, yeah, okay, but isn't that we have run out of time? Okay, so I would like to conclude this lecture. So first of all, we thank you very much for the Professor Hanus Leitgeb to giving this very wonderful and insightful two lectures at Wuhan University. Also, we would like to thank all the participation of our college and the audience in China or from other countries online. Also, finally, we would like to thank the technical support from the Xueshizhi. Without it, this will be impossible. So thanks them to provide such a very nice platform. Okay, it's time to say goodbye. Okay, thanks for all of you attending Professor Leitgeb's lecture. Also, thanks the speaker again. Okay, thank you very much. Okay.
Thanks so much. Thanks for the opportunity. Thanks for the excellent questions, and I hope to see you again very soon. Okay, thanks so much.
Yeah, we'd like to see you again in the future. Okay.
Look forward to seeing you.
Okay.